Let's say the laboratory experienced another 5% shift downward at a later date. Would we expect these exact same results? Would we expect it to affect 277 patient results, take 6 tries to detect, with 7 incorrect results? No, absolutely not. We would expect similar behavior, but not exactly the same because of the random nature of this process. So let's try this again. We have a QC event, and it is an accept. We run patients, and then the out-of-control condition occurs. This time it occurs 34 patient specimens prior to the next set of QCs. Let's continue testing. We have a bad result which we failed to detect. We continue testing, and at last we get a QC rule rejection. In this particular situation, it only took 3 QC events to detect the 5% shift downward. 134 patient samples were affected. 2 of the results were not fit for their intended use. 1 of those was prior to the last good QC event, and 1 was after. What if we repeatedly simulated this exact same out-of-control situation over and over? What we're seeing here are histograms of the quantities that we've been paying attention to. The upper left panel shows the number of unacceptable results that were produced prior to the last good QC event. We call this NUF. We can see that in half of the simulations there were no unacceptable results, but there was at least one situation where there were as many as 10. NUC represents the number of unacceptable results since the last good QC event. Here, in over 70% of the cases, we'd expect that number to be either 0 or 1. There were a few cases where it was as large as 4, but never greater than 4. NU represents the total number of unacceptable results. This is the sum of NUF and NUC. NQCE is the number of QC events to detect the out-of-control condition. In about 35% of the cases, that 5% shift was detected by the first scheduled QC after the out-of-control condition occurred. However, there was at least one situation where it took 10 QC events. NP is the number of patient results that were adversely affected by the out-of-control condition. % is the percent of the patient results that failed to meet the quality requirement while the out-of-control situation persisted. We see there is a wide range of possible outcomes that we could get from a 5% out-of-control shift. We can summarize our expectations by computing the averages for each of these distributions. If we do that, we find that the average number of unacceptable results prior to the last good QC event is 1.3. The average number of unacceptable results since the last good QC event is 0.9. The total is 2.2. The average number of QC events to detect the shift is 2.4. The average number of patients that were affected was almost 100. The percentage of the affected patients that were incorrect was 2.3%.